What's up, everybody? This next video lesson is going to be talking about a concept known as formal charge. Now, this video lesson was originally made for my AP Chemistry course, but the concepts can be easily adapted for honors chemistry. I hope you enjoy.
Formal charge is a quick calculation that you can use to evaluate non-equivalent Lewis dot structures like the ones that I just had on the last page. In order to calculate the formal charge, what you do for each element in a Lewis dot structure, you take the valence electrons that that element has normally, subtract the number of bonds it has touching it, and then also subtract the pairs of electrons, individual electrons, from that total. Ultimately, atoms are trying to achieve a formal charge as close to zero as possible. And if all the elements have a zero formal charge, then that's the preferred resonance structure of that Lewis dot structure. But if there ever is a situation where one or more of the elements carries a formal charge, then we need to decide using a couple of set of sub-rules to determine which is the preferred Lewis dot structure. The first rule, or the overarching rule, the one that governs the whole shebang here, is that atoms and molecules try to achieve formal charges as close to zero as possible. But if that's not possible, then we need to go to our next set of rules. So I'm going to redraw the three resonance structures that we built on the last page, and we're going to practice calculating the formal charge out for each one of the atoms in each one of these resonance structures, and then talk about what we're going to do from there. So let's start with the one on the left. Now I added the brackets and the charge for this polyatomic ion, and that is going to be a discussion point here shortly. But let's talk about the formal charge. Now let's start with carbon. Carbon has 4 valence normally, and I'm going to use red ink to determine or add up this valence. So 4 valence minus the total bonds, and since it's double bonded on both sides, that's 4 total bonds, because one bond is 1, double bonds are 2, triple bonds is 3. It has 0 dots, so its formal charge is 0. Now the sulfur normally has a valence of 6, and it currently has 2 bonds connected to it, and it has 4 dots, so its formal charge is also 0. Nitrogen, on the other hand, has normally 5 valence, and it's got 2 bonds and 4 dots, so right now it's carrying a formal charge of -1. Now the resonance structure in the middle, let's do the same thing. Carbon has 4 valence minus 4 bonds minus 0 dots, so it's 0. Let's do the sulfur. 6 valence minus 1 bond minus 6 dots, or it's got a -1. Nitrogen has 5 valence minus 3 bonds minus 2 dots, so now it's 0. See, by shifting the double bonds evenly, as you can see, to a triple bond and a single bond, you've changed the formal charges of the elements. On the one on the left here, the nitrogen had the -1 formal charge, and on the one on the center here, the sulfur has the -1 formal charge. Now let's finish up by doing this one over here. Carbon, once again, 4 valence minus 4 bonds minus 0, so it's 0. Sulfur has 6 valence minus 3 bonds minus 2 dots, or a +1 charge, and the one on the right, the nitrogen, has 5 valence minus 6 dots minus 1 bond. And I should do it in order, just so you don't get confused. So it's 5 valence minus 1 dot minus 6 electrons for a -1. Actually, this should be a -2, right? 5 minus 1 is 4, minus 6 is -2. So you've got 3 resonance structures, each with their formal charges determined. Let's talk about the follow-up rules now. The first sub-rule is that the sum of the formal charges in a resonance structure has to equal the ion charge. If you've got a neutral molecule, then the formal charges should add up to be 0. But in this case, since we have a polyatomic ion of -1, the formal charges have to add up to -1. It does in this first one, it does in this second one, and +1 minus 2 gives you a -1, does in this third one. Now, the rule that you talked about, or we talked about on the previous slide, is that elements prefer to have a 0 formal charge as much as possible. Now, this last one on the right actually has 2 atoms with the formal charge, and so that right there is going to disqualify this one compared to the other 2. The other 2 have 2 zeros and a -1 formal charge on the 3 atoms respectively. So we need to decide which one is going to have the -1 formal charge assigned to it. And whatever that one is going to be the preferred resonance structure. So the second rule is that Lewis dot structures are preferred with negative formal charges on the most electronegative element. Now I would have to tell you the numerical value of these two, but I'll tell you right now that nitrogen is more electronegative than sulfur, and so the formal charge of -1 should be applied to the nitrogen, and in this case, the first resonance structure is the preferred resonance structure of these three options. So I'll double or triple underline this one, tossing out the other two. You would use formal charge to determine the preferred resonance structure if you have non-equivalent resonance structures, like in this case. To summarize the rules, the first rule is the most important rule, that elements want to be as close to 0 as possible. If that's not possible, then you assign the negative formal charge on the most electronegative element, and then that is the preferred Lewis dot structure. And finally, double check that the sum of the formal charges is equal to the ion charge. Otherwise, you added something up wrong. Let's take a look at practicing assigning formal charges for another molecule, as you can see. We're looking at POCl3. Now let's assign the formal charge to each element. So let's start with the middle. Phosphorus has a valence of 5, and it's got 4 bonds and 0 dots, or a +1 charge. Now, the oxygen has 6 valence normally, and it's got 1 bond minus 6 dots, or a -1. And finally, the chlorines, which are all identical to one another, so you only have to do this one time if you have the same chlorine 3 times. Then you've got chlorine, which is a halogen, so they have 7 minus 1 dot minus 6 dots, 1 bond minus 6 dots equals 0. Now, since this is a neutral molecule, the formal charges should add up to equal 0, so that's good. It does, so we don't need to worry about that. And since there's only one resonance structure of this Lewis dot structure showing to you, then you can assume that this is the preferred resonance structure.
Well, that takes care of this video lesson. Thanks for watching.